Hello, it's Keith from Kinvert, and I want to give you a bit of a thought experiment. So there are quadratic equations, and occasionally the root is complex. And there can be different things that cause it, but the ultimate cause is that when you're looking at the discriminant, you end up with the square root of some negative number in there. Because remember, the quadratic formula itself is negative b plus or minus the square root of b squared minus 4ac. And all that's divided by 2a. And it is this area here, the discriminant, where if we end up with a 4ac value that is bigger than the b squared value, when you subtract that away, you end up with a negative square root, which isn't possible without complex numbers. Now, in standard form, the quadratic equation is ax squared plus bx plus c equals 0. Now, for it to be a quadratic equation, a cannot be 0. A must not equal 0. Otherwise, it's just like a linear function, right? A linear equation. And so a can't be 0. But c could be 0. B could be 0. We've already done an example where b was 0. Let me try to remember. I think that the equation that we did was 4x squared plus 25 equals 0. I think is what we did before, where we had a 0 term for b. Is it possible for there to be a complex root when c is 0? So before trying it on your own, I want you to think about that. Is it possible for there to be a complex root if c is 0? So take a look at the quadratic formula and see if there is any possible way for a complex root. Can there be a complex root if... Wow, is that seriously my best attempt at an F? That's still bad, but I'll leave it. Is it possible for a complex root if c equals 0? That's what I want you to think about and experiment with on your own. And I hope you pause the video. It's the K key to pause a video. I want you to seriously think about this for a few minutes, and then I'm going to show you why that is or is not possible. So please pause. We're going to go over the question, the solution here, kind of in 3, 2, 1. And we're back. Hopefully you thought about this. Now, this is not meant to be an in-depth mathematical proof, but what we're looking at is, can 4ac be greater than b squared if c equals 0? That is the question that we are facing here. Now, 4ac is the main chunk of this that we're looking at. Now, let's say you put 1,000,000 in for a. 4 times, I'll just put 1m for like 1,000,000, times c, but that'd be 0. Well, this is still 0. No matter how big or small of a value you have for a, no matter how big or small of a value you have for b, 4ac will always equal 0 if c equals 0. And so I'm predicting here, and this is not an in-depth mathematical proof, but at first glance, it looks like there is no possible way for a quadratic equation to have a complex root if c equals 0. Because no matter what you do with a, no matter what you do with b, right, you're just subtracting from this a 0. And so 4ac, no matter how big your a is, no matter how small the a is, if you're multiplying that by a 0, you end up with 0 for 4ac, and so now you just end up with the square root of b squared, no matter what else you do. So this was Keith from Kinvert. I hope this made sense. I mostly hope that you actually paused the video and thought about it for a bit. And yeah, we will see you guys later. Bye.